this is the most needed way to use a gasifier. Obtaining gas, electricity, or even gasoline from generator gas is undoubtedly profitable and interesting, but it pales in comparison to the fact that by 2025 half the world's population will not have access to clean drinking water. By the way, 1.3 billion people have no access to electricity today. And 2.1 billion people, mostly in Africa, Asia, and Latin America, have limited access to drinking water. It is great to produce gas, electricity, and fuel with a gasifier, but none of this is needed when there is no water. That's why water production with gasifiers is at the top of the list for thirsty people. This video is made on the basis of a recent work by Indian scientists made in 2018. They attempted to implement a system for obtaining water from air using a standalone refrigeration system on burning generator gas. They described a so-called atmospheric water harvesting system based on the steam adsorption cycle. This process allowed the extraction of 1.2 liters of clean drinking water from the air using 1 kilogram of gasified wood. Scientists have calculated that there are between 10,000 and 30,000 cubic meters of water in the air above 1 square kilometer of ground, even not considering the moisture in the clouds. And the Earth's atmosphere contains 14,000 billion liters of water. Water collected from the air in this way is akin to distilled water. Scientists have suggested using agricultural waste as fuel for a gasifier. I have already mentioned and detail hundreds of millions of tons of such fuels in the third world. There is so much of this waste that it is burned, and entire continents are covered with smoke. It is essentially conditionally free fuel. Figure 1 shows water collection methods. Table 1 shows their efficiency. Of the many methods, we chose steam absorption on the generator gas, which is shown in Figure 2. First, the gas heats water, then hot water starts the adsorption refrigeration process. The atmospheric humidity condenses in the heat exchanger, which corresponds to the evaporator of the cycle. The refrigerant takes up its heat. The refrigerant gives its latent and apparent heat to the water cooling. The finned air-cooled heat exchanger eventually gives off heat to the ambient air and feeds cold from the water to the water-cooled condenser. At the end of the process, the distilled water is mineralized not to harm health. The adsorption refrigeration unit was chosen because of its ability to operate on low-grade sources of thermal energy. It is shown in Figure 4a. The scientists have also estimated how much water can be obtained from the air in any given country, see Figure 5. Nigeria, Thailand, and Ghana, as countries with high humidity, are very favorable for obtaining it while Egypt and Iran are not. The system proposed by the scientists consumed 10.5 kilowatts of power. The process efficiency was 52%. See you.